All right, so electrons are arranged in layers called shells. Um, so the scientists that proposed that change to the theory, we had Rutherford, who had the nucleus and the electrons floating around outside, and then Niels Bohr added to that. And, so the model that we primarily use in our class is the Rutherford-Bohr model. So it's got the electrons orbiting, kind of like the planets would orbit the sun, except that it's not just an elliptical path around the nucleus. It kind of goes all over, but it's the same distance. Okay. Now there isn't actually a shell there, but we draw like a circle just so we can kind of see where it's at. So if you look at that animation on the first page, how many of you have seen something like this before? Jimmy Neutron. Everyone always says Jimmy Neutron or the Big Bang Theory. They've got those little things. So this is the same thing. It's just to represent a model of the atom. And this path, let's say the blue one's following here, that's just showing the distance. It doesn't actually just spin around in the same path every single time, but it stays at that distance. So that's why we kind of call them shells. Now for this one, you don't need to write down the letters. When you get to grade 10 or 11, you start referring to the letters. So we don't, the letters don't matter so much, so you don't need to draw this diagram, and you don't need to write the letters that are in here, but all the rest of this information you'll need. All right, so the first shell can hold 2 electrons, second shell can hold 8, third shell can hold 8. We're going to see if we can discover what the 4th, 5th, 6th, and 7th shells can hold, but you don't need to know those. We're going to stay pretty much in the first 3 for grade 9. We will go into the 4th one just a little bit. Now, the electrons that are on the outermost shell, they're known as valence electrons. So we're going to take a look at a few different models here and see what we can discover about them. So let's start with the most basic element that we've got. What's the easiest element that we have? Hydrogen. So element number 1. So if I wanted to draw the shell diagram for hydrogen, I can use H to represent the nucleus. So rather than drawing out all the protons, because when you get into the bigger ones, you can't really draw all the protons, all the neutrons, because you might be dealing with hundreds. So we'll start with hydrogen. So I draw hydrogen. How many protons does hydrogen have? 1. So if it's electrically neutral, how many electrons will it have? 1. So I'm just going to draw that right there, like that. Fancy schmancy, right? So there's my hydrogen atom with its shell diagram. Now, if we want to do the next one, what's the next one on the periodic table? Helium is number 2, so it has how many protons?
2.
And if it's electrically neutral, how many electrons is it going to have? 2. So we'll change that to helium. You'll add another one into your notes. I can just do it right here. And we're going to draw it with 2. Now, some people, for on their notation, they like to have the 2 electrons side by side on the first shell. Some people like to put it on opposite sides. For the first shell, I don't mind either method's fine. All right, I do it like that, which is a little lopsided, but it doesn't really matter. All right, so for the next one, what's our next element? Lithium. So we'll start fresh here. So lithium. So there's my nucleus, or the center. Now, how many protons does lithium have?
3.
So if it's electrically neutral, how many electrons?
3.
So we'll draw 1, 2. Now what's going on with this shell now?
Full.
It's full. So we can't draw that 3rd electron on there, so now we need to draw another shell. Now, very important to note, we fill up the inner shells first. Write that down. Fill up the inner shells first before you can move to the next one. So we have to put these 2 on the innermost shell, and then the 3rd one can go out here. If we add any more electrons, they go to the outer shell until that one's full. But we fill up the inner shells first, and then go on to the next one. Okay? So lithium has how many valence electrons? One. Because valence electrons are the electrons that are on the outermost shell. And lithium just has that one, way out there. All right? We'll do one more. Let's do beryllium. So beryllium is Be. How many protons does beryllium have? All together, come on.
4.
And if it's electrically neutral, how many electrons?
4.
So we draw our shell diagram. We've got our 2 on the inner shell. Can we put any more on that one?
No.
So now we draw the next shell. I'm going to put 1 on there. Can I put another shell out?
No.
No.
It's not full yet.
Not full yet, so I got to keep adding to this one. So beryllium's got 4 electrons total. How many valence electrons does beryllium have? 2. All right. What's going on? So we're going to skip ahead. We're going to draw fluorine. So here's how you should draw electrons on the second, third, fourth, fifth shell when you have more than just 1 or 2. Typically, you draw them in pairs, and you spread them out in pairs around that shell. So we all said that fluorine's going to have 9 total. It's going to have 2 on the inner. It's going to have 7 on the outer shell. So then you would draw that one lonely one off by itself there. So there's neon with its 8 on its outer shell. Let's do one more shell diagram. Let's take a look at sodium. All right, so where's sodium? What number is that? Number 11. Okay, so sodium has how many protons?
11.
And if it's electrically neutral, how many electrons?
11.
How many on the inner shell?
2.
On the second shell?
8.
On the outer shell?
1.
So it's got 3 shells, right? So we'll draw that out really quickly. By the way, girls, another tip when you're drawing these, make sure you draw the electrons large enough so they're actually noticeable. Please don't do this and say that that's an electron, okay? Make them big enough so that you can see them, or that I can see them, which is more important when I'm marking your quizzes and tests. Okay, so there's sodium, but we need to add another shell, and I've run out of room. So I'm just going to quickly move sodium over a bit. Sorry if it's a little hard to read on top of the periodic table there. And there's that 1 electron floating off by itself. So sodium will have a 3rd shell. Now if we take that, we're going to shrink it a bit to make it more manageable. And we'll put it over in the general area of sodium over here. Okay? So how many valence electrons is magnesium going to have?
2.
And then when we get to aluminum?
3.
And then silicon?
4.
And then phosphorus?
5.
Sulfur?
6.
Chlorine?
7.
Argon?
8.
And then what do we say, what happens when we reach argon? What's with the 3rd shell? Okay, it's full. So then what are we going to have to do? What's the next element? Well, where's the next element? Hey! So then we have to go all the way over to potassium, and that adds a 4th shell. What happened when neon was full? Where did we have to go for that? To sodium, and we added another shell. What happened with helium? Added another shell. So what do you think, girls? What do you think is going to happen when we reach krypton here? We're going to add another shell, and we're going to have to go over here to number 37.
18 on the 4th shell.
How many did the first shell hold?
2.
So if we look at hydrogen, and 1, helium has, okay, and And then we moved on to the next shell. How many did this shell hold, the second shell? 8. And look how many elements we've got. 1, 2, 3, 4, 5, 6, 7, 8. How many does the third shell hold? 1, 2, 3, 4, 5, 6, 7, 8. So I didn't tell you in your notes how many does the fourth shell hold, but do you think we could figure it out?
Yeah.
Yeah. We started potassium.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
So how many does the fourth shell hold?
18.
How many does the fifth shell hold?
18.
How many does the sixth shell hold?
18.
Ah, I don't know. Don't forget, we have to add in 58 to 71. They fit right there. So it's not 18.
So we're wrong.
Well, for number 6 you are. But that's okay. You didn't know about those guys.
They're the full ones.
Yeah.
They're the shells.
All the guys over here in yellow, that's where the shells are full. So they have a full outer shell. So what can we say about fluorine, chlorine, bromine, iodine, and astatine?
They're all 7.
Not 7, because the shells can hold different amounts, but they're 1 away from being full, right? They're just 1 short of being full. So all of these guys here are 1 short of being full. What about oxygen, sulfur, and all the rest of these guys? How many are they short?
2.
They're 2 short of being full.
Oh my God.
Okay? What about lithium, sodium, potassium, all these guys? What can we say about them? What do we know? They add a new shell. So how many valence electrons do all of these guys have?
1.
1. So all of these have 1 extra electron. What can we say about beryllium, magnesium, and the rest of these guys?
2.
Yeah, they've got 2 extra electrons. Now for grade 9, I've told you that we look primarily at the first 3 periods. So probably up to argon, and we do look at potassium and calcium. And we do look at some of these guys over here a little bit. But this whole section in the middle, we tend to ignore a little bit because it doesn't follow the same pattern. There's a whole bunch of special cases and special rules. So when we're looking at bonding, ionic and covalent bonding, which is a topic we're going to cover in a later class, we tend to ignore all this stuff in the middle here just because there are a bunch of special rules. So we try and teach you the simpler patterns, and then when you get to grade 10, 11, and 12, you start to learn a lot more of the special rules, okay? So, atoms are happiest when their outer shells are full. I use the term happy just in a silly way there. In nature, things tend to try and find balance, and atoms are no different. So atoms want to try and find balance, and they're balanced when their shells are full. So that's what they will try and do, okay? So they're going to share, they're going to give, they're going to take in order to complete their outer shells. And this last statement here is really important. Atoms will do whatever is easiest, usually. And what that means is, when we talk about humans giving and taking, which one is nicer, to give or to take? No, the answer was give. You're supposed to say give. So giving is something that's nicer and it's easier to give things away rather than go and take something, right? So in the atomic world, it's just about the numbers. So if you have 3 and you need to go and find, you can either give away 3 or go find 5. It's easier to give away 3. All right. If you need 1 and you've got 7, it's easier to take 1 than it is to give 7. So it's just purely about the numbers. Okay. So let's take a look at this lithium atom that we've got here. Let's start with what we have. So we'll list all the different things about this lithium atom. All right, so that's all the information about this lithium atom there. But is this lithium atom happy? No, because lithium does not have a full outer shell. So looking at it from a pure numbers perspective, what could lithium do? How many would it take to fill up this outer shell? 7 electrons. So is it easier for lithium to go find 7 electrons, or is it easier for lithium to kick out this one? It'll kick out the one, and that's exactly what it'll do. Lithium will kick that 1 electron out and end up looking like this one over here. Okay? So now let's write down all the information we know about this lithium. So we have 3 positively charged particles with the protons. We have 2 negatively charged particles with the electrons, because we kicked one out. So our net charge is going to be +1, because we've got 1 more positively charged particle than we do negative. So our charge now is +1. This lithium is called an ion, and that'll be in our next set of notes. But this lithium atom here is now happy. It's got a charge on it, but that's not that important to it. It's important that it has that full outer shell. So it went down to its inner shell, but this inner shell is full. So it's happy. Okay? So it has a charge though.